Let's take a closer look at carbohydrate digestion. Before we even consume carbohydrates, cooking them can soften fibrous tissues and make them easier to chew and swallow. Once we consume carbohydrates, enzymes made by the mouth, pancreas, and small intestine participate in the process of digestion. You'll notice that most enzymes end with ASE, ACE, and target corresponding sugars ending in OSE, OSE. So, before diving into digestion, let's quickly take a look at these enzymes and the sugars they break down. The enzyme amylase digests starch in the mouth or the small intestines. Maltase in the small intestines breaks maltose into two glucose molecules. Sucrase turns sucrose to glucose and fructose. And finally, lactase breaks down lactose, also known as milk sugar, to glucose and galactose. Now that we're familiar with enzymes, let's take a step-by-step look at carbohydrate digestion. First, salivary amylase, secreted by the salivary glands in our mouth, break down starch to shorter saccharides such as maltose. This happens when we chew food for a long time in our mouths. If you have a saltine cracker handy, you can experience the first part of carbohydrate digestion yourself. Rub off some of the salt so you can better taste this reaction. Let the cracker melt in your mouth or chew it for a while. You may notice a hint of sweetness as this process occurs. What you are tasting is a breakdown of starch to shorter sugar molecules. However, since food doesn't stay in the mouth for very long, little digestion occurs at this stage. Salivary amylase is then inactivated in the acidic stomach environment, and no starch digestion occurs there. The pancreas releases the enzyme pancreatic amylase into the small intestine. The absorptive cells of the small intestine release maltase, sucrase, and lactase, converting disaccharides into monosaccharides, which can in turn be absorbed. At this stage, sugar molecules undergo active absorption or facilitated diffusion to enter the absorptive cells of the small intestine. Glucose and galactose need a carrier and energy as they are pumped into the absorptive cells along with sodium. This is active absorption. Fructose is absorbed via facilitated diffusion, which uses a carrier but no energy and is slower than active absorption. So when we eat large amounts of fructose, it cannot be absorbed quickly enough and can result in diarrhea. This occurs because fructose sticks around in the small intestines and attracts water in the process. In the absorptive cells, some fructose is converted into glucose, and the sugars enter the portal vein headed to the liver. The liver, in turn, metabolizes monosaccharides galactose and fructose into glucose. Fiber escapes digestion and enters the large intestine, where it is fermented by bacteria. The rest is finally excreted.